Thank you for coming along this afternoon. My name is Jason, and today I'm going to talk to you about the state of Salesforce DevOps. The plan today is to do a bit of a whistle-stop tour around what DevOps is, why it's important, and what it looks like. We're going to cover a lot of stuff fairly quickly, so bear with me, and if you do have any questions, then feel free to grab me afterwards. So before we go any further, a little bit about me. I'm Jason. I'm head of customer success at a company called GearSet. We're a DevOps tooling vendor on the Salesforce platform. We've been building DevOps tools for different platforms for the last 10, 15 years. I guess the starting question for me is, show of hands in the audience here, who here is comfortable explaining what DevOps is if someone asked them? No, one or two. Okay, not very many. I think that's probably fairly sort of realistic of the environment here, which is that DevOps is a fairly new concept in the Salesforce world. Traditionally, you had this concept of release management, where you had developers building software, and then your IT teams or your infrastructure teams managing the hosting, the support, the infrastructure, and the testing for it. DevOps is a new concept where actually you're bringing those two processes together. So you're no longer having a separation between software development and infrastructure management. It's all managed by the software development team. And really that involves three main shifts. The first one is one of empowerment. Basically, because you're going to have a single team managing that whole process end to end, it makes it much easier for them to own it. It means that you don't have to worry about handing off responsibility, waiting on different teams to manage the process, and that gives you a little bit more empowerment to own the whole development process. The second one is automation. So manual and repetitive tasks are just difficult, they're complicated, they slow down your release cadence. So if you can automate the process, that's really, really powerful, and it removes some of the ceremony that's traditionally associated with deployments. And if you can remove that ceremony and make it more automatable, that makes it more repeatable in the long term. And the third one really is accountability. By having the whole one team manage the whole process, it's much easier for them to own it end to end and solve any problems that you come back along the way. And the end result really is what DevOps gives you is agility. It allows you to build faster, deploy faster, manage changes more efficiently, and get those changes out into the hands of your end users. So, just bear with me while the slides click through. Oh, here we go. Why is it important then? That's the question of, aside from being an interesting technical challenge about automating releases, making the pipeline work faster, there are lots of business reasons why you should actually consider adopting DevOps process. The first one really is that it allows you to release faster with lower risk. And that means that you can get whatever it is that you're building into the hands of your end users more quickly, and that means that they can start to see value from it more effectively. And that then helps you get more ROI from your investment in Salesforce. If you can be building features, shipping them more quickly, getting your sales teams more enabled to make sales, that means you can make more money from your Salesforce license investment. And really it's also kind of important because it's the future of development on the platform. When you look at things like Salesforce DX, the new tools that are coming in, the idea of Git being your source of truth, all of this is underpinning the idea of DevOps as the new process that you should be using to manage change. And that really gives you a competitive advantage. This is not just the traditional competitive advantage where you're an ISV and that means you can get software out the door more quickly. It's also just if you can get your team to be more effective at using your data from your customers, it means that you can sell more effectively than your competitors, whoever that is in whatever business you operate in, and essentially get more ROI out of your Salesforce investment. It's worth saying that that DevOps varies a lot depending on the platform that you're working on. So you've got three main categories it falls into. Traditionally, you have your legacy on-prem software here, represented by a traditional database symbol. That's where you're looking after the hosting, the infrastructure, the software, the hardware management, the whole thing end to end, which gives you the most control, but obviously requires the most input and management from you as well. The second one in the middle is where you go for cloud hosting. So you've got Azure here, for example. That abstracts away the management of the hardware, so they deal with all the infrastructure and the computers for you, but you're still significantly looking after the software management, patching, releases, and all of that. And then the far end of the service is when you get to platform as a service with a tool like Salesforce. You essentially give them a credit card and they provide you with everything you need. You just log in and go from there. That obviously makes it easiest for you to manage because you don't have to worry about scalability or testing or any of that infrastructure management, but you also lose some control over the infrastructure, control over the process, and you a little bit more removed from that. So when we bear in mind about Salesforce specifically, the definition of DevOps is a little bit more constrained than other platforms because you're no longer worried about the infrastructure. You're no longer worried about executing your tests because Salesforce will manage that for you. It basically falls into any part of your release cycle which is currently manual but has the potential to be automated. So that's traditionally things like deployments and releases. You're tracking changes across different environments, dev, QA, staging, production, testing your code, and then backup as well. So we kind of talked about what Salesforce DevOps is, but one of the other questions is, why is it happening now? Why in the last couple of years has this shift from release management to DevOps happens? And really, it's partly to do, and significantly to do, with the introduction of Salesforce DX. So traditionally, you had release management, which was all about getting the code out the door, moving on with your life, and then planning the next release. DevOps is all about having that really, really integrated flow where you're quickly pushing changes out. And although it was possible to do that traditionally, it was really, really tricky because the first-party tools were a little bit lacking. Salesforce DX has been a real enabler in allowing teams to build a modern development flow, and that's partly because of the new metadata format that it introduced. So I don't know if you can see that on the screen, but you have a traditional object there in the metadata API format, single large file, Salesforce DX format, where it splits it up into individual component objects, which make it much easier for you to work on those files in parallel. It also introduced things like scratch orgs, so the idea of a new ephemeral environment that you can spin up when you need it from source, make some changes, and bin it when you're done. And you've also got things like second-generation packaging or developer-controlled packages or unlock packages, whichever you want to call them, which is a new way of segregating your code into smaller chunks, which means that you can version it more easily and then manage those changes across different environments. And all of this together has really enabled this push for DevOps being the future of how you manage your change. And at the core of that is the integration with things like source control. And this push towards DevOps that Salesforce has taken really required them to have more reliable DevOps tools, and that's what Salesforce DX was really bringing to the fore. So from a super high level, what does DevOps look like? We're going to dive into more detail, don't worry, in a little bit. Traditionally, it falls into 5 sections, which is build, where you're writing your code, you're writing your Apex tests, you're writing your profiles, permissions, whatever it is. Second stage is deployment, so you're going to actually get this out to a staging environment so you can test it. Does your integration test pass? Are there any obvious errors that you need to fix? Does it go past user acceptance testing? Once you've done that, you're going through your testing, and then it goes out into release. So let's get it into the hands of your end users so they can actually start using whatever it is that you've built. And then finally, you have this idea of ongoing monitoring and maintenance. So keep an eye on what's happening. Do I need to make feedback? Do I need to iterate on it? Is there a bug I need to fix? So that's a very conceptual diagram. It's not really very useful for many people. So what we're going to dive into is a bit more of a practical guide to what does it actually look like when you build a DevOps platform traditionally, and how does it look like when you implement that in Salesforce. So there are 2 approaches to building a DevOps platform. The first one is to build a set of platform agnostic tools, and the second one is to use tools a bit more designed to deal with the nuances of working in Salesforce. And we're going to run through both in turn. So taking a platform agnostic approach, there are 3 things that are going to be core to your toolbox. The first is going to be your dev tools. So you've got things like Sublime, your IDE, you've got VS Code, whatever it is where you're making those changes and writing your code. The second part of it is going to be your source control. So this might be your on-prem hosted GitHub, it might be Bitbucket, GitLab, whatever those systems are, but that's the bread and butter for managing changes to your files over time so you can see what's going on. And then the third pillar is going to be some sort of automation tool. So traditionally, this might be something like Jenkins or Circle CI or Bamboo. This is the bit of software that you're running in a data center somewhere. It's taking your code, executing a build script, and then deploying that out to your target environments. And they tend to require a little bit of management and infrastructure on your end. So what we're going to do is we're going to jump into an actual example workflow of what does it look like if you're building that platform agnostic process for DevOps in the Salesforce world. So what we're going to do is we're going to start here with our dev working in our master branch in Git, because obviously master is a representation of your production environments. And the first thing they're going to do, because they don't want to work in master, because you wouldn't work in production, is create a feature branch to work in. Now, traditionally, this is going to be using some kind of CLI for your Git system. You're going to be creating your branch from there. Once you've got your branch, a separate place to work in, you're going to then want to create a scratch org so you can make those changes. Now, again, you're going to be using the Salesforce DX CLI here, using the force org create commands, and then referencing your scratch definition file, which is going to be somewhere in your Git repository. Once that's been created, you're probably going to load this scratch org with some metadata from your repository, maybe some sample test data, so you can get it into a structure that you can work on reliably. Then from there, you're going to follow the fairly standard process of make changes in your org and commit those into your feature branch over time to build up the feature that you're working on. And again, this is traditionally done using the CLI, so you're going to be using the force push commands and then putting in your commit messages so your team can track what's going on where. Over time, you're going to build that work, and when it comes to the point where it's ready to be released, you're going to want to open a pull request or merge request, whatever it's called in the different systems, and that's going to be asking to push those changes into your master branch so they can actually be released out. And that's going to be where your code review comes in. So making sure that your team has insight into what you've changed, making your release managers get approval into it to see what's going on. You're going to feed static code analysis results in or integration testing to make sure that code all works as expected. Once you've been through that, you're going to merge that code into, in this case, a QA branch. And this is where some of the automation kicks in. So we mentioned automation servers earlier. Somewhere in a data center, you're going to have a Jenkins build or a TeamCity or Circle CI build, which is going to be watching that QA branch. And as soon as you've merged that change into pull requests, that's going to trigger it to run some scripts, which you're going to have created to take that change and push it out into your QA sandbox for testing. So these might be test scripts, they might be deployment scripts that have been created by your development team, and they'll be just essentially run fairly blindly by your CI automation server. When it gets into QA, you then go through your standard user acceptance testing, log into the org, does the button where I expect, do I have the permissions I expect, how can I release this out? And then you're going to want to actually release this into your production environment to get it in the hands of your end users. So the next step, you're going to repeat this process of PR, but in this case it's going to be going from your QA branch into master. So again, you go through code review, you get sign off from your release manager, and then you get it merged in. And again, your automation system is going to be watching your branch. In this case, it's going to trigger another set of scripts to grab those changes and push them finally out into production and in the hands of your end users. So that's all great, but this entire process so far has been basically based around using CLI, using manual scripts that you're managing for your Jenkins builds, and it's pretty dev heavy. So the question is, where do your admins fit into this? Where do the people who are working directly in sandboxes who can't work with CLI tools fit in? And the answer is they don't really. They're traditionally still going to be working in a sandbox somewhere. They're going to be pushing those changes from a sandbox, probably using change sets into QA and then out into production. And so the problem you have is how do you capture those changes back down into your Git flow so that they're not overwritten the next time an automated release comes out from underneath you? There is no good answer for that in this traditional model. It's just something that's really, really difficult. And so what you end up with is maybe a flow that works fairly well for the devs, but for your admins or your release managers, they don't really fit into this process. You end up running into merge conflicts, and it's all going to be a little bit tricky. So it was possible to do this, but it is tricky. So the other approach that you can go down is, we'll go in pros and cons before we jump on from that. We talked about it a little bit, but basically the pros of being this platform agnostic process that gives you full control. So you can design this process from scratch. You can manage all of the settings of your Jenkins builds. You can choose exactly which integrations you want to build. You have total management over the entire flow. And that's great, but it does also mean a management overhead. You have to have someone looking after this process. You have to have someone upgrading those release scripts every time a new Salesforce platform release comes out because maybe there's a change to how the API operates. And that's something that's just a fairly high overhead for you to look after. There's also, as a benefit, the fact that you have on-premise data sanctity. If you're hosting all of this infrastructure in your own data center, it's never going anywhere but you and Salesforce. It gives you a nice management over exactly where that data is coming and going. And also, if you're a big company, you might just have this infrastructure. You might have a data center lying around with a load of servers that you can use to just host this stuff, so it actually might be fairly cheap for you to set up. But as I said, there's a lot of overhead that comes with this. There's also a security risk. As good as you think your data center management is, it's probably not as good as AWS's, so you're realistically going to have more chance for security breaches by managing things internally. One of the big ones is really around effectiveness. If you're using a blind CI tool like Jenkins or Circle CI, it's designed to work as an automation tool for any platform, so it's not going to be able to deal with some of the nuances of how metadata works on the Salesforce platform. And that can lead to challenges actually making this process really robust. And as we mentioned, it's just very, very dev-centric. How do you get people who aren't familiar working command line tools integrated into this flow? And the answer is it's very, very tricky. So the second thing you can look at is then moving into building a slightly more Salesforce-specific DevOps toolbox. There's a lot of similarities, but there are a few key differences that will help this process work a little bit more easily. So you're still going to start with your dev tools. You're going to have VS Code. You're going to be leaning a bit more heavily perhaps on the SFTX CLI. You might be working in Notepad, whatever your text editor is of choice. You're then still going to have source control, because source control is absolutely key to this. Having that single source of truth is something that you've probably seen all over the Salesforce DX documentation. But in this case, you're probably going to be using hosted versus on-premise. So it's going to be GitHub Online, it's going to be Bitbucket, GitLab, VSTS, whatever it may be. And then the real big change is you're going to not use a blind automation tool, but something designed specifically for the Salesforce platform. So I come from a company called GearSet. There are obviously other companies out there doing similar tools on the platform, but there is a real difference between using something that's designed to deal with Salesforce specifically and something that's just designed as a generic automation tool. And we're going to explore what that looks like as we jump into a slightly more Salesforce-specific DevOps process using these different tools. So we're still starting from the same starting point. We have our devs, in this case our admins, working in our master branch in Git. And the first step we're going to take, just as before, is we're going to create a feature branch. But using a DevOps tool, you don't have to go into the CLI. You can generally do it with a couple of clicks of a button. That makes it much easier for everyone to get involved in that process. The next step is you're going to be creating a new Scratch org. Again, if you want, you could use the SFDX CLI, but actually it's much easier if you can just use a few buttons in the UI, select the properties and settings of your Scratch org, and then spin it up in a few seconds. Then you're going to go through the same process, log into your Scratch org, make the changes, run comparisons, and then commit those changes into your source branch over time. And again, this is something that you can do without using the command line. It's a very, very friendly process for everyone. When you've got this feature ready to release, you're going to open a pull request. Again, this is something that you can do in most DevOps tools, so you don't have to bounce out to a command line to do this. The actual process of code review is pretty similar, and it's one of the key things that you can't skip in this process. You want to get your whole team to have feedback on that code. You want to have them pulling it apart and telling you what works and what doesn't. Make sure you still get that release manager approval, and that's something that's going to be done still in your source control system because that's basically what they're designed to do. Once that code then gets released, you're going to have a continuous integration job, which is going to be picking that change up and deploying it out to your QA sandbox. But the key difference here is that by using a DevOps-specific tool for Salesforce, you don't have a separate data center somewhere which is running that script from Jenkins or Circle CI. You don't have something which is relying on manual updates every time the platform release comes out. Once you've gone through QA testing, then obviously you're going to repeat that process of opening a pull request, merging into master, and then having a job which builds that deployment and pushes it out into your production environment. There's a couple of ways you can do this. You can either have it done by full CI, so as soon as you push into master, it just gets punted straight out to production, or you can have a sort of a validation setup where it builds a package, checks that it's ready to go, but then holds it pending your approval. But the key difference here is that this is a single process that works for people who are used to the CLI and people who are used to working in the UI, and it doesn't require command line tools, it doesn't require complex setup, and it doesn't require ongoing maintenance. So as we kind of talked a little bit there, it basically reduces the management overhead significantly. You have a lot of advantages of tools specifically designed with the nuances of how to work with metadata in the Salesforce platform. You get updates and support. You can lean on other people. If your Jenkins build fails, you can talk to GearSet or you can talk to any of the other companies out there. But there are some downsides. It might cost more. You know, if you have that data center already, then you're going to spend more money on another subscription service. You do sacrifice a certain amount of control over the integrations by handing this out to a third-party vendor. And if you are a traditional development shop, this may be a different process to what you're expecting in other parts of your business. So, in the last couple of minutes, I'm just going to quickly talk about some of the challenges that you typically see when teams come across this process. Many teams, especially with DX, are really, really looking to jump into the deep end and say, hey, I work at Chainsets at the moment, and I want to suddenly bring CI in 3 weeks. Doesn't really usually work that easily. There's a lot of change, partly in process, partly in making sure people are aware of what's going on, getting buy-in from the whole team, making sure the whole process works really well. So it's important to plan the vision carefully and do it in steps and not try and run before you can walk. Another big one is not really knowing what good looks like. Every team is different, whether your breakdown of dev heavy, admin heavy, what your experience is, what the end goal is. It's going to shape what that actual solution is going to look like for you. So it's important to know what you're aiming for and stick to that as you go. And it's important that that process works for the whole team. Because if you have a process that works for devs, but not your admins, then the process will fall apart after a few months because everyone will go back to the previous ways of working. And one of the traditional limitations is just that the first-party tools like Salesforce DX, they're designed for devs. It's called the developer experience, it's not called the admin experience, and so there's a gap there in terms of getting the whole team on board. So we've done a very, very quick overview of this, I realize in 20 minutes, of what DevOps is and why it's important, kind of what it looks like. But it's important to remember that this is not a flash in the pan. DevOps is a well-established concept in many other development platforms, and it's something that's here to stay in the Salesforce world. But that said, Salesforce has its own unique aspects, and this idea of the system developer is still going to be important. You're not going to stop people from working directly in orgs just because of your source-driven process. You need to have a process that works for that whole flow to enable that change to come out really quickly. And you'll see that increasingly a lot of the new platform tools and the latest features that Salesforce are bringing out, they're all building on this idea of DevOps, of single source control as the source of truth, as automation and CI, and it's going to become increasingly more important over time as the platform just matures and gets more and more complex. And I think that is me out of time. Thank you very much.